Alright, hi you guys, and today we'll be talking about the polar form of a linear equation. Alright, so the polar form of a linear equation, it's going to look like this. It's going to be rho, which looks like a lowercase p. I'm not going to write p because most people go, oh, it's p. It's not, it's rho. Is equal to r cosine of theta minus phi. Okay, so that's pretty much just the formula set up right there. Now, phi is the angle made with the standard position or the pole. Sorry, that shouldn't be pole. That should be the polar axis. There we go. Okay. All right, so here's the steps. Write an equation, ax plus by equals c in polar form. Okay, first you convert it to standard form, which is ax plus by minus c equals 0. Then you find the normal form. So first you need to find the value of c, which in fact we're not actually finding c, even though it's going to be the same spot. It's going to be, we're finding it's something like c. Okay, so find the value of the plus or minus square root of a squared plus b squared. And when c is negative, we use the positive one. Okay, now p will equal c. Okay, well, p will equal whatever that is, whatever we choose. Whatever we choose for that. And then arctangent of AB will equal phi. Okay, and let me write this out. Phi real fast is alt 237. There we go. Think about what quadrant the angle it is from the sine and cosine. Okay, so we're going to actually work with a problem so you can see how this works, and it will all make sense when we get there. Okay. Alright, so here's the form. Here's the actual linear equation. Now we're going to write it in polar form so we can graph it. Okay, so 2x minus 7y plus 5 equals 0. Okay, so this is all set up like this. So first off, I'm going to actually convert it to normal form. So converting it to normal form, I need to do plus or minus the square root of 2 squared, which is 4, plus 9 or 7 squared, which is 49. So this is going to be equaling probably, well, since c is positive here, we're going to be using the negative version. So negative the square root of 53. Okay, so that's going to be that. So when I convert it, it should be 2 divided by, it should be negative 2 divided by the square root of 53, and this is going to be the x. Let's try that again. Negative 2 divided by the square root of 53 x plus 7 divided by the square root of 53 y plus 5 divided by the square root of 53 equals 0. Okay, so when you convert it to normal form, you just divide by this number. Oh, and this should turn into a negative version. There we go. Okay, I forgot about that negative part. Okay, now what's going to happen is rho, and I'm going to use lowercase p just to denote rho right now, is going to be negative 5, and this, we're going to have this on top. So I'm going to rationalize it real fast. So this is going to be 5 root 53 divided by 53. Okay, so that's going to be rho. Alright, and then I'm going to set up cosine and sine. Okay, so cosine of phi, so this is cosine of phi is going to be negative 2 divided by root 53, and sine of phi is going to be positive 7 divided by root 53. Okay, now what I need to do is set up the equation. Tangent of phi, 237, is equal is equal to sine over cosine. Okay, which is going to be 7 over root 53 divided by negative 2 divided by root 53. Okay, now if you notice, I'm going to flip and multiply by the reciprocal, so this is going to turn into negative 7 halves. Okay, all right, now what I'm going to do is to get phi, well actually I'm going to think about it first. Okay, cosine being negative and sine being positive, okay, the only place where that happens, okay, if we use our rules, A, smart, trig, class, okay, the only place that happens is in the second quadrant, so our angle has to be over here. So tangent is going to be negative as well. And if you remember your principal values, sine and tangent are going to be principal values over here, whereas cosine is going to be positive, or the principal values are going to be here. So when we do this, we're going to get a negative angle, okay? So we need to add 180 to it to actually get the right angle, okay? So once again, Alt 237 is going to equal arc tangent of negative 7 divided by 2. Oof. Let's back off the caps lock a little bit, Mr. Devaney. Okay, and if we do that on our calculator, okay, we should get phi is equal to negative 74.05 degrees. Okay. All right, now that is not good enough for us, so we need to add 180. Okay, which once again proves the theory of the principal values. Okay, so we add 180 to that. So we go negative 74.05 plus 180. And we should get phi to actually be equal to 105.95 degrees. Okay, now that we've got that, we can actually set up our equation, because the equation was that. So we are going to be using negative parentheses 5 root 53 divided by 53 equals, if we go back to our formula over here, it's rho equals r cosine theta times theta minus phi. So it's going to be r cosine of theta minus phi, which is going to be 105.95. Okay, now when we graph this on our actual graph, it should look like this. Okay, so how you would actually set this up is you would just set up in this form, and you would just solve for each value of theta that you're plugging in. You would solve for r. Okay, all right. And so this is pretty much just how it's set up as a line. If you'd like to learn how to graph it on Desmos, here's another one. Okay, and so here's the actual graph of the line. Now what I did was I made sure my graph was in degrees, and then I divided both sides by cosine of theta minus 105.95, and voila, you actually have your line. Now if you were to superimpose the two that we started out with, I believe, here, let me look up what was the first one. If we had, what, 2x minus 7y equals negative 5. It's very close to the original, but it's just a little off. So that probably means I made a miscalculation somewhere. Oh, there we go. There we go. So I did make a miscalculation before, so let's go check out to see what error I did. So this helps double check your work to see if you did it correctly. Okay. Okay, so if you look right here, C is going to be negative when it originally was positive until I divided by the negative of root 53. So this should have never been there. So down here, this negative should have never showed up. Okay, now you can make your table of values, but honestly, if you just divide both sides by cosine of theta of theta minus 105.95, you'll get the same answer as what I did. Doing this one, you're going to get some decimal approximations, but at least they're going to help you out with your angles and everything you need to work with, okay? All right. But that is it for polar form of a line in standard form. I'll talk to you guys later.